Brazing is one of those basic skills that all service technicians must master. Without this skill, you simply can't do your job. Brazing is defined as the joining together of metals using heat. It is also commonly called soldering, sweating, or welding. Generally speaking, brazing takes place at temperatures above 800 degrees Fahrenheit. Because the procedures we'll be showing take place at those temperatures, we'll use the term brazing to describe the process. In this program, we'll teach you the fundamentals of brazing with an emphasis on its application in air conditioning and refrigeration systems. The process involves the use of flame and pressurized fuel gases that are potentially dangerous. Because of this, we'll stress safety throughout the program. When working on any piece of equipment, always follow the specific instructions outlined in the manufacturer's installation instructions or maintenance manuals. General safety precautions you should follow when brazing include avoiding contact with flux. It can irritate your skin and eyes. Wearing safety glasses and gloves. Keeping a fire extinguisher and quenching cloths handy. And working in a well-ventilated area. Some of the fumes generated during brazing can cause irritation. We're only covering the more important safety issues in this program. Safety standards covering welding, cutting, soldering, and brazing are available from your state safety and health agency or from OSHA at the federal level. Your employer should be aware of these standards and must comply with all of them. In this program, we'll deal with two common brazing alloys. The silver-bearing alloy, commonly called silver solder, requires the use of a flux, but flows at a lower temperature. It is suitable for joining dissimilar metals, such as copper to steel or copper to brass. It is also quite acceptable for joining copper to copper. The copper-phosphorus alloy, commonly called Fosco, Silphos, or Foson, does not require the use of flux, but requires a higher temperature to flow. It is only used to join copper to copper. Both of these alloys require high temperatures to flow. There are several fuels and brazing systems in use that provide varying levels of heat. They also have varying levels of versatility. In this program, we'll emphasize oxygen-acetylene. Using this combination, a service technician has the versatility to handle any air conditioning or refrigeration repair. Brazing is like riding a bicycle. It is an acquired skill that takes practice to learn. Work with a more experienced technician and practice brazing at a workbench. Use scraps of tubing until you become proficient. Do not practice on customers' equipment, as an improperly made joint can leak, causing a service callback. Our technician will be demonstrating the various procedures in a workbench setting. Before we start brazing, let's review some safety procedures that must be followed when working with oxygen and acetylene. Keep the cylinders away from heat, sparks, or open flames. Store and transport the cylinders in a secured upright position. Keep spare cylinders capped when not in use. Do not use oxygen to pressurize a system to check for leaks. Before installing the regulators, check for damaged threads. Do not use any oil or grease on the tank or regulator threaded fittings. Oil or grease in contact with oxygen will ignite or explode spontaneously. Prior to connecting the regulators, stand to one side and crack the valve slightly. Then close it. This burst of pressure will blow out any dirt or debris that might have entered the valve. Have the regulators backed off, counterclockwise, before attaching them to the tanks. Back them off until no resistance is felt. The oxygen tank fitting has right-hand threads. The acetylene tank has left-hand threads. Notice that the oxygen hose is green and the acetylene hose is red. With the regulators attached to the tanks, we can light the torch and start brazing. We'll be brazing a copper tube to the service valve assembly of a residential condensing unit. First, we'll make the joint with a silver-bearing alloy, and then with a copper-phosphorus alloy. The first thing we must ensure is that the pieces to be joined have good fit and proper clearance. The belled end of this service valve is designed to accept refrigeration-grade tubing. The clearance between the male and female fitting should be about 3/1000ths of an inch. That's about the thickness of a sheet of paper. Using refrigeration or ACR grade tubing and fittings ensures good fit and clearance. Never use fittings or tubing made for general plumbing use. These materials do not conform to the higher cleanliness standards required in a refrigeration system. Use a tubing cutter so that the ends of the tubing to be joined are square. Also, deburr the tubing. The tubing to be joined must be clean. If there is oil or grease on the tubes, remove it with a solvent. Use sandcloth to remove any oxide coating. This ensures a good metal-to-metal bond. Support the tubes to be joined. In this case, the vise is providing the support. This step is important because parts will expand when heated, causing them to come apart if not properly supported. Now, flux the joint. In a refrigeration system, apply the flux after the tubes are assembled. This minimizes the entry of flux into the system. Flux keeps the metals to be joined from oxidizing as they are heated and allows the filler metal to bond properly. Remember, flux can irritate your skin and eyes. Wash off any flux that gets on your skin or in your eyes. Prior to lighting the torch, stand to one side and make sure the oxygen regulator is backed out, counterclockwise. Never stand in front of either regulator. A defective regulator could blow out, causing injury or death. Make sure the acetylene valve on the torch is off. Then open the oxygen valve on the torch to purge any gas in the regulator and line. Stand to one side of the regulator and open the valve on the oxygen tank slowly. This prevents damage to the regulator. Adjust the regulator clockwise. A setting of around 10 pounds pressure is more than adequate for air conditioning repairs. Then shut off the oxygen valve on the torch. A similar procedure is followed with the acetylene. Make sure the regulator is backed out counterclockwise. Open the acetylene valve on the torch to purge any gas in the regulator and lines. Stand to one side of the regulator and slowly open the acetylene tank valve. Never open this valve more than 1.5 turns. Adjust the regulator clockwise. Never adjust the acetylene regulator above 15 pounds pressure. A setting of around 5 pounds pressure is adequate for air conditioning repairs. Then shut off the acetylene valve on the torch. We're now ready to light the torch. Open the acetylene valve only and light it with a friction lighter. Do not use a match or open flame to light the torch. Open the oxygen valve and adjust the flame to get a slight feather or ragged edge on the inner cone. Reduce the oxygen until the feather edge just disappears. Now, apply the torch to the joint. Heat the male tube first. Don't allow the inner cone of the flame to touch the work. Keep the torch moving for uniform heating of the parts. Notice that we've wrapped the service valve body with a wet rag to protect it from heat damage. This would also have to be done on an actual unit installation. The flux will bubble as the water boils off. Then it will become white and puffy, and then clear. When it becomes clear, it is an indication that the metal is hot enough to flow the filler alloy. Apply heat to the female and touch the silver alloy rod to the junction of the two tubes and see if it flows. Do not heat the rod directly. If the metal is hot enough, the alloy will flow. Move the rod around the circumference of the joint while still applying heat to the female. The alloy is drawn into the joint by a process called capillary action. Heat on the female helps promote this flow. This powerful force can overcome gravity and will draw the filler metal into a joint even if it is upside down. To work, however, the parts to be joined must have proper fit and clearance and be clean. After the joint is made, quench it with water. This serves two purposes. It cools the joint and the water washes away the flux. It's important to remove any flux residue as it is slightly corrosive and can cause eventual failure or leakage at the joint. Make a habit of inspecting your work Check for leaks and make repairs if needed before evacuating or charging the system. Here, we've sectioned a brazed joint. Notice how capillary action has pulled the filler alloy deep into the joint. Many service technicians prefer to use a fluxless copper-phosphorus brazing alloy when making copper-to-copper connections. This brazing alloy contains phosphorus that performs the same function as flux. The same preparation procedure is followed as previously described, except flux is not used. Although this alloy is more forgiving of dirt or oxide on the parts to be joined, it is still a good idea to clean the metal with solvent and sandcloth. The same basic process of heating the metal and applying the brazing rod is used. The phosphorus copper alloy needs a slightly higher temperature to flow and does not flow quite as easily as the lower temperature silver alloy. After the joint is made, cool it with water and inspect it. Sectioning of the joint shows that the alloy has achieved good penetration by capillary action. When done brazing, shut off the cylinders. Back off the regulators. And bleed off the lines and regulators through the torch. Now that we've successfully made some brazed joints, let's review what we've just covered. Brazing involves heat, flame, and flammable gases under pressure. Follow all safety precautions. Work with an experienced technician and practice brazing using scraps of metal tubing. Do not practice on customers' equipment. Follow these 6 steps to ensure a good brazed joint. They are: provide good fit and clearance between the parts to be joined. This can be accomplished by using refrigerant or ACR-grade tubing and fittings. Clean the parts to be joined by removing oil or grease with solvent and removing any oxide coating with sandcloth. Assemble and support the parts to be joined so they don't come apart when heat is applied. Flux the parts to be joined. This step is not required if a copper-phosphorus brazing alloy is used. Heat and flow the filler alloy. Capillary action will draw the filler alloy into the joint. Remember, good fit and cleanliness are required for capillary action to take place. Clean the joint to remove any flux residue. If left on the joint, flux can cause corrosion. Inspect the joint and make repairs if required before evacuating or charging. This completes the training program on brazing. Your distributor can provide you with additional service skills training.